Welcome to the DIY Honda Garage channel. The DTC P26F2 refers to a fault associated with the starter cut relay diagnosis circuit, which has detected a low voltage condition. This condition arises when the input voltage of the starter cut relay diagnosis line is below a defined threshold, signaling to the powertrain control module, PCM, that there is an anomaly when the engine is in an off state. The PCM is responsible for controlling various engine functions, including the starter relay and its ability to detect potential issues with circuits. If the conditions indicating that both DTC P26E5 and P26F2 are present simultaneously, this may affect the diagnostic approach and need to be reviewed together. The location of the starter cut relay and the related components is crucial for any inspection or repairs. Typically, this relay is found within the relay circuit board, which is located near the engine compartment. Understanding this fault, including the roles of the ECM and the diagnosis circuit, is essential before proceeding with further troubleshooting steps. The starter cut relay diagnosis circuit is a critical component in the starting system of the Honda Accord. It is responsible for regulating the voltage supplied to the starter motor, ensuring the vehicle can start smoothly. When identified as having low voltage, it indicates that the circuit may not be functioning properly, which can result in the vehicle failing to start. This relay is integrated within the relay circuit board, situated in the engine compartment, making it relatively accessible for inspection and testing. The circuit essentially acts as a guardian, monitoring any abnormalities that could impede the engine from initiating. When low voltage is detected while the engine is off, the powertrain control module records the DTC P26F2 to alert the technician of a malfunction in the starter cut relay diagnosis line. When diagnosing the DTC P26F2, there are several potential culprits that could be responsible for the detected low voltage. The first possibility is a faulty relay circuit board, which may have internal issues affecting its operation. Without an operational relay, the starter motor cannot receive the necessary voltage to engage, leading to starting issues. Another common issue could be a shorted external circuit, such as the wires connecting the starter cut relay to the PCM. If these wires are compromised, they could either short to ground or become damaged, impacting the relay's performance. Finally, if all other components check out, issues related to the PCM itself may need consideration, as it could be misinterpreting the signals or not supplying the correct voltage. Each of these causes needs to be thoroughly evaluated during troubleshooting. The symptoms associated with DTC P26F2 are largely indicative of issues with the starting system of the Honda Accord. One of the most common symptoms is the inability to start the engine, which results from the starter cut relay not being able to receive the required voltage. Without this operational voltage, the starter motor cannot engage and the vehicle will remain non-starting, leading to potential frustration for the driver. Additionally, if the error codes for P26F2 are displayed on the diagnostic tool, it signifies that the PCM has identified an anomaly in the starting circuit, prompting the need for inspection. These symptoms often require immediate attention, as they can lead to further electrical issues if left unresolved. Furthermore, interrelated symptoms may arise within the starter relay circuit, necessitating a comprehensive diagnostic procedure. The first step in troubleshooting DTC P26F2 begins with attempting to start the engine. This initial action helps determine if there are immediate, observable effects linked to the starter cut relay's performance. After trying to start the engine, it's crucial to turn the vehicle's ignition to the off lock position. This step ensures that all electrical systems and components are reset and can safely be observed during the next stages of the diagnostic process. Following that, the ignition should be turned to the on position without starting the engine for at least 5 seconds. This waiting period allows any voltage that might be present in the starter cut relay diagnosis line to stabilize, enabling a more accurate assessment for the next troubleshooting steps. Overall, this process aids in gathering essential data about the current working state of the vehicle's starter system. In the second step of troubleshooting for DTC P26F2, it is essential to perform a relay circuit board test. This test focuses on the starter cut relay 2 circuit to confirm whether it is functioning correctly. The inspection will help ascertain the integrity of the relay, as any faults here could lead to incorrect voltage readings and inhibit the starting process. The procedure includes checking the relay's condition, ensuring that the connections are secure, and assessing for any visible damage or corrosion which could affect performance. By conducting this test, technicians can either eliminate the relay circuit board as a potential fault or identify it as a component requiring further action. This step is crucial as it lays the foundation for determining if the fault lies within the relay or elsewhere in the system. The third troubleshooting step involves a comprehensive inspection of the external wiring associated with the starter cut relay. Specifically, technicians should examine the STRLY_22 wire and the ST-cut RLY2CL wire for any signs of short circuits or damage. A shorted wire can create an unintended path for current, resulting in improper function or low voltage conditions that trigger the DTC P26F2. This inspection should be meticulous, looking for frayed insulation, exposed wires, or any connections that may be loose or corroded. As part of this process, disconnecting the necessary connectors, such as the relay circuit board and PCM connectors, is essential to safely assess the conditions of these wires. By ruling out issues with the wiring, one can narrow down the cause of the low voltage condition effectively. In the fourth troubleshooting step, technicians must conduct a detailed inspection of the powertrain control module, PCM. After ruling out the other components, if they are functioning correctly, the PCM may be at fault. This inspection involves analyzing all test results thoroughly to identify any discrepancies or issues within the PCM itself. The PCM is the brain of the vehicle's engine control system. If it misinterprets the signals from components like the starter cut relay, it can lead to immediate and ongoing starting issues. Checking for shorted circuits in the wiring connected to the PCM is crucial. Any erroneous signals could lead the PCM to act upon incorrect assumptions about the starter system's functionality, cementing the importance of this step in confirming or eliminating the PCM as the cause of the DTC P26F2. The final repair verification step for addressing the DTC P26F2 requires clearing the diagnostic trouble code from the vehicle system. This action effectively resets the onboard diagnostics, allowing the system to monitor for any reoccurrence of the issue. After clearing the code, it's essential to test the vehicle's functionality, specifically focusing on whether the engine starts without issues. Testing will confirm the success of the repairs performed and verify that the starter cut relay and its associated components operate correctly. Technicians should pay close attention to the starter system's performance over repeated cycles, ensuring reliable ignition without any abnormalities. If the vehicle starts as intended and the DTC does not reappear, it indicates successful resolution of the underlying issue related to the starter cut relay diagnosis circuit. Preventive maintenance is key to avoiding problems associated with DTC P26F2 in the future. One essential aspect is to regularly inspect all wiring connected to the starter relay and the components of the relay circuit board. Over time, wear and tear can lead to shorts or breaks in the wiring, so proactive checks can help in early identification of potential issues. Additionally, regularly testing the starter relay circuits can ensure they are functioning properly and within the required voltage thresholds. Keeping abreast of the vehicle's electrical systems is critical, as they play an integral role in overall functionality. For vehicles, particularly modern ones like the Honda Accord, electrical integrity is paramount for optimal performance. Routine diagnostic checks can facilitate timely maintenance, ensuring that the starter cut relay and PCM are always in peak operational condition. In summary, DTC P26F2 highlights a low-voltage condition in the starter cut relay diagnosis circuit, impacting the starting capability of the Honda Accord. The diagnosis process focuses on inspecting the relay circuit board, external circuits, and the PCM for faults. Symptoms typically include issues starting the engine and error codes triggering from the PCM's detection system. By following a structured troubleshooting approach, technicians can pinpoint the root causes of the problem, whether they lie within the relay, wiring, or PCM itself. Additionally, conducting preventive maintenance can minimize the potential recurrence of such issues, safeguarding the integrity of the starter system. Understanding these components and their functions will ensure the longevity and reliability of the vehicle's starting mechanism. Please like and subscribe to the channel. See you next time.